Hey guys, this is BJ again from Complete Developer Podcast here doing my homework assignment. Yay, online classes. They don't stop when the world ends, apparently. Just kidding, the world is not ending. We're just going through some rough times, y'all. Remember to wash your hands, don't touch your face. So, got four problems here. This is assignment 6, which strangely enough, I'm recording before assignment 5. Uh, Long story short, assignment 5 is doing the problems we did on the test a couple weeks ago, so I'm going to wait and do that next. So this is compute the greatest common divisor or denominator, um, wanting us to use this terrible method name GCD. Ugh. Look, I like more descriptive names. I don't like using comments in code because comments lie. They may not lie at first, but eventually they will because code changes over time. And it is better to name your methods, name your variables, so that someone looking at it knows what's going on. Anyway, here's what this is doing. Basically, we're inputting two integers and calculating the greatest common denominator based on a recursive function. We are learning recursive functions. Well, uh, some of us for the first time, some of us just learning how to do it in C++ again. Yeah. All right, so let's run this and see how it goes. Yes. All right, so anybody have any choices on integers? I think we're going to do 12 and 30. These are the one I've been testing because I know the common denominator here is 6. Boom. Really cool. Pretty straightforward. There we go. As you can see, recursive calling back itself till it finds that largest one there. All right. Moving on to our next one, reverse digits. Set that as a startup project. All right. This prints the digits in an integer backwards. Pretty straightforward. Already actually solved this problem. Not doing recursion. Now we're having to do it with recursion. So kind of cool, actually. So I got lazy. I just went and copy and pasted the main and then the call to the method. I went in and wrote a recursive method for it. So, all right, let's run this. All right, integer to reverse. Let's make it a long one, and we're going to be simple. 1, 2, 3, 4, 5, 6. 6, 5, 4, 3, 2, 1. Boom, we did it. Pretty straightforward. It just, I mean, like I said, we've already gone over this one. Um, we look at the output, the number mod 10, divide it by 10, and then recall the function with that new number. Before it was a loop. Nothing new here. All right. So, scroll up to the top here. This one was actually kind of a little bit of a challenge. A lot of fun. I enjoyed writing this one. This was converting a decimal to hex. I had to look up some stuff like on how to do that. So it posed a good challenge for me. I enjoyed doing it. So walking through it, here we are. We're entering in our decimal number, our integer here, our hex value, our string, is calling our recursive function. Yeah, it was a bit of trial and error here. So that was kind of fun. Because one thing that I was running into, which was rather weird, is when I would mod it with 16, I would get 0. And so played around with a couple of different things. Eventually got it working. So our mod 16 was 16, you get 0. So let's run this and check it out. So if we throw out 1 through 10, we're going to get 1 through 10. So let's throw out 14. We get E. Let's do it again. Give it a larger number. How about 164? A4. Cool. Straightforward. Right, guys? Awesome. And now moving on to the bane of my existence the last few hours. This has been. Let's just say I never want to see 8 queens in one place at a time, ever. Uh, so, the 8 queens problem. We've seen this before, but before only had to display a possible solution. This time I actually have to solve it using recursion. So, here we go. Declaring our vegetables, variables. Oh my goodness. Can you guys tell I've been shopping? Initializing the board, so basically setting everything to 0 on the board. And then we call our function. It returns a Boolean value, not necessary up here on the initial call, but that is useful later on as it calls itself, because we're going to be checking that it is returning a true value, that it's actually doing this, because if it throws a false, then we need to move on. First thing, check that we stop at the last column. You know, if we throw in a column that's greater than the 8, then we need to just go, hey, time to stop, return true. So then we check each row of that column. We do our no attack. So if this returns true, then there is not any attack vector here. So what that looks at is the horizontal of the left. So since we're going from left to right on the columns, we don't have to look at the right side because the right side is going to be empty. So all we're looking is at the horizontal left, the upper diagonal left, and the lower diagonal left. And so going in here, we are looping through, and we're just looping through the columns for that row, just checking that horizontal. Since we're going down by column, we know we're not going to have anything in that column. Then we go upper diagonal left. So we're setting I equal to row, J equal to column. And then we're going until both, while either one of them doesn't get to 0, and subtracting from there. If one of them is a 1, which equates to true, then we return false. So if there's a 1 in that column, or in that position, going back up the diagonal, then we return false. Hey, it's not no attack. Yeah, double negatives are fun when you get into Boolean algebra. Well, not really Boolean algebra, just dealing with Booleans. Whew, headache. Then we go down here to the lower diagonal left of the column. So we've gone up this way. Now we're going down this way from it. Again, we set I equal to row, J equal to column. And so we're looking here is your column is going backwards, but your rows are going up. And if we hit anything in that, again, we return false, that there is an attack vector there. And if that's the case, we move on to our next row in that column. Once it hits 1, it places a 1, which represents a queen, in that position, and then calls itself again. And keeps going until it returns true. So that's basically here. Or if there is an issue, it returns false here. And then, then it puts a 0 in that position in the board and moves on to the next one. So what this does is it goes through it, and then in the recursion, if it hits a point where it can't go, it goes back, it falses back up to that place and then goes again and keeps trying until it finds one. So then it sets Yes, so it sets the board there. Then we come back here and we print the board. Pretty straightforward. We just loop through I for row, J for column. And so I got a little fancy here. Instead of just printing out ones and zeros, I did queens and blank spaces or underscores here. So when you see it, it looks kind of neat. So here we go. Boom. Awesome. Pain in the rear end to get this thing to work. I will be honest with you. I would get like, it would go and it was just figuring out what happens if it, it gets to here and then it can't find any more places to put it. Yeah, like that was not a fun thing to figure out. Gave me a lot of stress. Thankfully, my girlfriend was very kind to me during that time earlier this evening. She has left, so she is not here now to come and take a bow for that. All right, guys, that's it. Like I said, remember, wash your hands, don't touch your face, avoid large crowds, stay safe out there.